To save physics, Erwin Schrödinger decided to run away with his lover. It turns out that love can be useful. He wrote his most famous equation in the arms of his lover during that trip. The story goes back to 1925. Physics was in chaos because Heisenberg described electrons as jumping randomly. Only cold probability numbers remained. Physicists hated this. They argued, where was elegance in physics? Schrödinger also deeply disliked this. To fight Heisenberg's ugly theory, that Christmas at 38, he secretly went to a remote Swiss villa with his old lover. There, away from everything, passion and intellect mixed, with remarkable reaction, he wrote the world-changing equation, the Schrödinger equation. In his equation, the electron was a smooth musical wave. Physicists were relieved. The quantum jump was finally gone. The world seemed elegant again. Schrödinger thought his wave was the real electron. He thought he had saved physics. But just months later, physicist Max Born clarified things. The Schrödinger equation was correct, but the interpretation was wrong. The wave wasn't the electron, but the probability of finding the electron. The equation calculates where the electron might appear. But when you look, it instantly collapses to one point. This is wave function collapse. Schrödinger was upset. It turned out he gave a precise mathematical form to what he tried to deny. To defend his view, he went to Copenhagen to meet Niels Bohr. That visit was a nightmare. In 1926, soon after Schrödinger arrived, Bohr began debating him. Bohr was like a tireless debate machine. They argued from breakfast until late at night. A few days later, the exhausted Schrödinger fell ill. But Bohr didn't stop. Schrödinger lay in bed, weak and feverish. Bohr sat by the bed, handing him water while chanting like a monk. You have to admit atoms do jump around randomly. You have to accept it. Schrödinger felt despair. If this quantum leap existed, he would rather never had studied physics, but Bohr smiled. We're grateful to you. Your equation is very useful. Schrödinger, traumatized, fled the humiliation, planting a seed of revenge in his heart. 9 years later, that seed grew into a monster. In 1935, to attack the Copenhagen school, he designed Schrödinger's cat. A cat in a box with a radioactive atom. Within an hour, the atom has a 50% chance to decay. If it decays, it releases poison and kills the cat. If it doesn't decay, the cat would live. So, before you open the box, is the cat dead or alive? According to Bohr's quantum rules, the atom is in a superposition, both decayed and not decayed. So the cat is also in a superposition, both dead and alive. Schrödinger finally finished writing and smirked mockingly. See? This is exactly how absurd your theory. How could a zombie cat possibly exist? He thought this would finally wake people up. But physicists calmly agreed. Yes, that's exactly what the math says. Soon, this zombie cat became famous. But this led to an even bigger question. If the cat's life or death depends on observation, then does the universe itself need someone to look at it to exist? The Copenhagen answer was blunt. Don't ask, just calculate. But some weren't satisfied. In 1957, Hugh Everett spotted a loophole. What counts as observation? Is it human eyes? Does the cat observing itself count? Does a camera count? If observation causes collapse, Whose gaze kills the cat? Everett proposed an idea. What if the wave function never collapses? When you open the box, the world doesn't choose between a dead or a live cat. Instead, it splits. This is the many worlds interpretation. When Adam faces a choice, the universe branches like a tree. When you open the box, in one world the cat is dead. In another, it is alive. Both are real, and you split too. This means with every quantum choice, the universe splits. Observation creates new worlds. Every second, countless versions of you are born, while countless versions die. This led to the quantum immortality thought experiment. If you point a quantum gun at yourself, in most universes, you die. But in one branch, the gun doesn't fire. For that surviving version of you, you will live on. Everett showed his idea to Bohr, but he was ignored. He thus left physics. He worked on nuclear models, drank heavily, and died young. Only later did people take his idea seriously. Schrödinger later also regretted. He once said, "I'm sorry I ever had anything to do with it." But his cat is famous now. It could never be put back. Classical physics promised us an objective stage. It said that we were the audience. But quantum physics says we help create it by looking. Whether by collapsing reality with our gaze or by splitting worlds with our choices, we are part of the show. Physicist John Wheeler once drew the universe as a giant U. It began with the Big Bang and evolved until humans appeared. Perhaps that is the real purpose of the universe after waiting for 13.8 billion years. So, when you look at the moon, remember, you are not just seeing it. You are helping the universe confirm it still exists.